All right, guys, Mr. Antonucci here, and in this video, we're going to talk about the definite integral, and we're first going to talk about forming Riemann sums. So we're going to investigate sums that have the form sum I equals 1 f of ui times delta x, and we're going to use the following more general assumptions than we did previously, where the function f is defined on a closed interval a to b. The function f does not necessarily have to be continuous on that entire interval, and it does not have to necessarily be non-negative on that entire interval. So the widths, delta xi, would be xi minus xi sub I minus 1 of the subintervals xi minus 1 comma xi, where I is 1, 2, 3, 4, so forth, and so on up to n. In other words, we're going to partition this into n subintervals, and they don't necessarily have to be equal in width. The number ui may be any number within each subinterval. So if you go from, like, let's say 1 to 2, then the ui could be any number in that subinterval. Then the sum I equals 1 to n of f of ui delta xi is called the Riemann sum for f on the closed interval a to b. And that's actually the foundation of integral calculus for us. So let's go ahead and do an example here to kind of get some concrete behind what we're talking about. So the function x squared minus 3 from 0 to 6, we're going to partition the interval into 4 subintervals listed here, and we're going to find the Riemann sum for which ui is the left endpoint and ui is the midpoint of each interval here. So a couple things to notice. The first interval goes from 0 to 1. Okay. The second interval goes from 1 to 2, so right here. And then the third interval goes from 2 to 4, right here. And then the last one goes from 4 to 6. Now, for part A, I'm going to use the left endpoint of each subinterval. So the first subinterval goes from 0 to 1. I'm going to use the left endpoint, so it's actually a rectangle below the graph. The next subinterval goes from 1 to 2, and the function value is still below the graph here, so it's that rectangle. Then I go from 2 to 4, the left endpoint is right here, and then from 4 to 6, the left endpoint is right there. So the sum of I equals 1 to 4 of f of ui delta xi is going to be f of 0 times 1 plus f of 1 times 1 plus f of 2 times 2 here, because the third subinterval is 2 units wide. Remember, we said they don't have to necessarily be all the same width. And then f of 4 times 2, that would be the last rectangle. So this is going to give us negative 3 times 1 plus negative 2 times 1 plus 1 times 2 plus 13 times 2. And this is all going to simplify down to 23. Okay, but notice these rectangles are below, these rectangles are above. These ones that are below are going to stick out underneath, and these ones are going to have some gaps here for those ones. So the next thing we want to do now is use midpoints of each subinterval. So for part B, here we go now. The f of u1, the first subinterval, the midpoint is actually at 1/2. So that's going to be f of 1/2 times 1. Okay, so the midpoint is at 1/2, that first subinterval, so you get the function value. But then you still have to multiply it by 1, which is the width. Now, even though 1's not going to change the value, we still need to multiply by 1 to indicate that we're getting area there. Plus, the next subinterval's midpoint is actually at 3/2. So f of u sub 2 is going to be f of 3/2, which in this case, if we evaluate the function, that would give us -3/4. Let me not multiply this by 1 just yet. I want to get the actual function value at at 1/2, which is going to be -11/4. And then the third subinterval goes from 2 to 4, and the midpoint is actually just at 3. So f of 3 is going to give us 6, and then f of the fourth value is going to be the midpoint of the fourth interval, which goes from 4 to 6. So the midpoint is just at 5. So that gives us 22. Now the Riemann sum, we're just going to add those function values and multiply each one by the width of their respective subintervals. So ui delta xi. So now we're going to have -11/4 times 1 plus -3/4 times 1 plus 6 times 2 plus 22 times 2, which is going to end up being 105/2, or 52.5 for that one. Okay, so that's it for this piece. Reach out if you guys have any questions. Take care.